Alright, what is up my homies? Welcome to Brainmelt University. Today I've got a bit of an apology to make. You see, I kind of jumped the gun with my last video talking about dynamic routing protocols when really I should have taken a step back and looked at the difference between dynamic routing and static routing in the first place. I get excited about dynamic routing protocols. It's one of my favorite topics to discuss. It's also one of the most diverse and dense portions of the computer networking world, and so there's a lot of different directions that conversation can take. But really, in order to understand it, you probably need to take a step back and think about what routing is in the first place. So that's what we're going to do today. We're going to talk about static versus dynamic routing, what routing actually does, what those dynamic routing protocols are designed to accomplish, and as always, if you find this video helpful, please feel free to like, subscribe, hit the notification bell, and share any questions, comments, or concerns you have in the comments below. So with that said, let's go ahead and get started. The first thing we need to discuss is actually a topic that really you only started seeing discussed a few years ago. This is something that's been around for just about as long as computer networking has, but with the introduction of things like software-defined networking, these terms really started to hit the forefront. When we're talking about what a router is designed to do, we need to take a look at three different planes. These planes represent the different tasks or what is going on with that particular device at any given time. The top plane is called the management plane. This is where you as a network technician are going to be interacting with this device, whether you're logging in using some sort of console, whether you're using some sort of controller device to log in, or whether you're logging in through, say, a web browser if it's that type of a device. Your management plane is where you are giving instructions to a particular device and configuring it so it can actually do its job. Below that, we have the control plane. The control plane is in charge of decision making for that device. So kind of think about management plane as you being the boss telling the device what to do, and the control plane is that device actually making the decision of how it's going to accomplish your orders. This is where dynamic routing protocols live. This is also where static routing lives. This is what allows it to make a decision of how it's going to actually perform its function, whether this is a switch, a router, a firewall, whatever. These are the pieces of data it has at its disposal so it can make a decision. At the very bottom of this model, we have the data plane. This is also sometimes referred to as the forwarding plane. The data/forwarding plane is actually in charge of forwarding traffic, whether it's forwarding frames, forwarding packets, or some other type of PDU entirely. Dynamic routing protocols are how routers make the decision to forward particular traffic. Dynamic routing protocols live in the control plane, and it's how they gather the information for how to make a forwarding decision. Now that we've knocked that out of the way, let's actually move into the difference between dynamic routing and static routing. On this channel, we like to focus on the what's, the whys, and the hows, what something is, why we use it, and how it works. But unfortunately, when we're talking about dynamic routing versus static routing, most people just stop at the what. Everyone can kind of figure out that something that's static is never changing and something that's dynamic is changing as needed, but that's really only focusing on what. A dynamic routing protocol just allows a router to update its routing table, that piece of data that it needs to make a forwarding decision when a change occurred. Static routing is something that doesn't change. This is something you've manually configured, and so if something breaks and that route is no longer usable, you as a human have to go back in and log in and change that information to where it starts working again, and that router can start effectively routing traffic again. Logic is the major difference between dynamic routing and static routing. The logical difference versus something that's just static or something that's dynamic is where your device is learning this information from. If your device has to learn its information from human input, that means that it is static routing. However, with dynamic routing, your device is no longer having to learn that information from a human. Instead, it's learning that information from its peers, the other devices in your network that is doing similar tasks, or other devices in other networks that it's directly connected to which it can exchange data. With static routing, you have to know exactly how a packet must reach its destination network. You need to know that if a router wants to send information to a network, let's just say it's the 10.0.0.0 network, then you have to know where the next router in line is that can get that packet where it needs to go. And you have to do that for every single destination network you're trying to reach. This can get pretty time consuming very quickly, especially if you're in an organization that has a lot of network segmentation going on. Static routing is really only effective for small networks because otherwise you're spending a large amount of time having to manually program route after route after route into a device's routing table. Static routes do have one major purpose when it comes to large networks, and that's for creating what's called a default route. A default route is if a router does not know how to process a packet, it's going to make a default decision every time. This basically is passing the buck on to someone else, and hopefully they will be able to get it where it needs to go. If you look at the routing table on virtually any home router or Soho router, you're going to only see two routes in that routing table. One is to the directly connected network, the one that's created as soon as you pull it out of the box, and one is a default route that passes all unknown traffic to the internet service provider. This is why you normally have an interface that's marked WAN on your small devices so that you know that's the interface you need to connect to the internet service provider so they can actually forward traffic. If you don't do that, if you connect them backwards, it's not going to function. Your average home router that you buy off the shelf at Walmart, Costco, or Best Buy is not going to be the most powerful device. It's going to be something very small, and it's not going to have the most capabilities out there. Instead, your internet service provider is going to be using routers that weigh several hundred pounds sometimes and are going to be extremely powerful. They're going to have lots of storage, and they're going to maintain routing tables with several 100,000 entries. This is why we can get away with only having two routes on your average home router. Your internet service provider's router is going to have a much better idea of how to process that traffic than your typical plastic Wonder Soho router. Most of your cheaper consumer routers do not even have the capability to do dynamic routing. These are protocols that are used exclusively by enterprise or larger service provider networks. The way that a dynamic routing protocol works is that you as a human only have to configure the protocol itself and tell the protocol what information you want to share with other routers. So for instance, if I have a small enterprise network that's comprised of 3 routers and each of those 3 routers has 3 networks connected to them, then for every single router in that network, I would have to configure a minimum of 6 static routes. Those 6 routes would be for the 6 networks that each router is not directly connected to. But things get sticky if you add a 4th router that also has 3 networks connected to it. This means that you have to configure that 4th router with 9 networks that it's not connected to, and then you have to go to each of your 3 pre-existing routers and program in 3 more static routes for the ones that were just added. This shows just how difficult static routing is when it comes to the concept of scalability. Instead, we need to focus on dynamic routing when we start working with enterprise network. All you have to do is configure what protocol you want to use, whether you're going to be using RIP, OSPF, EIGRP, or something else. If you're not quite sure what these different dynamic routing protocols are or how they work, I will link my video on them in the description below. With dynamic routing, you only have to tell your router what networks it wants to advertise to other routers. Using a dynamic routing protocol, now instead of having to program every router with every network that it is not directly connected to, you only have to tell it what information it needs to share with other routers. This means that all 3 of your pre-existing routers would only have to advertise 3 networks, and then when you add that 4th router into the mix, it only needs to advertise the 3 networks connected to it. All of the other routers will automatically share that information with the other one as long as all of these routers are configured to use the same protocol. This makes scalability a breeze when it comes to adding additional routers or layer 3 devices into an existing LAN, WAN, or other type of enterprise-specific network. Not only do dynamic routing protocols recalculate routes to ensure that they're taking the most efficient path, but they will also advertise their directly connected networks to any new routers that are added into a network automatically, so long as that new router is configured with the proper protocol. This drastically cuts down on the amount of time it takes to configure a new router as you add it into an enterprise or service provider network. So that pretty much adds our whys and hows to my earlier discussion on dynamic routing protocols. Without that little bit of context as to why you would use a dynamic routing protocol over just statically configuring, it can be a little difficult to justify why we have to learn these different protocols that all come with their own theory, their own terminology and nomenclature, and having to memorize how these things actually operate. Yes, it does make learning networking a lot more complex to have to go that in depth into each individual protocol, but at the end of the day, understanding those protocols makes your job a lot easier if you're working with a constantly scaling network or a constantly changing network where you're constantly adding and removing networks as necessary. So there you have it. That's dynamic versus static routing. That's the logical difference versus just saying one changes and one stays the same. And with that, I think we can wrap up. I should have just tacked this into the other video. I realized this as I was editing it and figured, hey, new video material. Let's pad the algorithm. If any of you have any questions, as always, please drop them in the comments below, and I'll see you here next time on Brainmelt University.